Hello, Gauri here. I'm from BCA Data Science Semester 3, and my topic for our programming is Movie Recommendation System. I have created this program in R Studio. So before demonstrating my code, I would like to share a little bit about my project. It is an item-based collaborative system wherein I will be suggesting movies to users on the basis of the ratings they give to movies. I have imported my dataset from Movie Lens dataset. My dataset is divided into two parts, movie data and rating data. In movie data, I have three columns and over 10,000 rows. And in rating data, I will have four columns and over 10,000 rows as well. Now, starting with the code, we will first need to install the packages which I've already installed. So we are simply going to just call them. Recommender lab is a very important package. It is used in many recommendation algorithms and it is also used to test them. ggplot is a data visualization package and reshape is used for data manipulation. We have also installed data.table package. Now we will import our data set. As you can see, this is our data structure which is visible in the output. This is my data summary and the first 6 entries of movie data. Now I will be doing the same with rating data. This is the summary of my rating data and the first 6 entries. Now we need to process the data as the entries we have in movie IDs and user IDs are in the form of integers. We need to convert movie genre also into a more usable format, which we are going to do over here. So this is what is being implemented over here basically, and this is the output that we will get. Now we need to create a search matrix for searching movies, which we are going to do with the help of cbind function. Now this is the output that we will get after using the cbind function to create search matrix. Now we are going to convert our rating matrix into sparse matrix. Now we need to find similarities between movie and also similarities between users. For that we are going to use cosine operator and find similarities between users and movies. These similarities are visible here. You can see on the right, we can see a plot of user similarities. Now we will be doing the same with movie similarities. Now what we are going to do next, here on the right you can see movie similarities plot. Now we are going to extract unique ratings and create a count of movie ratings. And you can see this is the output that we are getting. Now what we have to do is create a list of the most viewed movies. So we are going to basically count views for each movies and create a list of the most viewed movies. Now, once we create a list for the most viewed movies, we will have to create a bar plot of these most viewed movies, which we are going to do with the help of ggplot. Now, after that, we are going to be creating a heat map of movie ratings. Now, while the heat map and the bar plot are loading, we will do data preparation. In data preparation, what we need to do is find the most usable data, after which it has to be normalized and binarized. After that, here we have a heat map of top users and top movies, which will also be loading shortly. And we will visualize average ratings per users. Now, normalizing data. What is normalizing data exactly? Now, normalizing data is nothing but uh, when there is a lot of data and a lot of movies, they can have different kinds of ratings and they can have different values. We need to create a common scale of values for this in order to avoid distortion. That's what we are going to do in data normalization. So now our bar plots have been loaded. We will have a look at them first before proceeding. This is the bar plot of most viewed movies that we had created using ggplot. Here we have created a heat map of first 25 users, and this is a heat map of top users. After that, we had created a distribution of ratings in users. So these are all the plots that we have plotted till now. Now we will go ahead and normalize our data. After normalizing our data, we have created another heat map of normalized ratings of top users, which is visible on the right over here. Now we need to binarize the data. Binarizing data is nothing but assigning values. What we are going to do here is assign value 1 to all the movies which have ratings above 3 and 0 to all the movies which have ratings below 3. Now we have created another heat map after our data is being binarized. This is a heat map of top users. Now we will explore parameters, sample data. Our data set is distributed into 80% training data set and 20% testing data set. Now what we are going to do next is we are going to retrieve the recommendation model using get model function. And after that, we are going to find the class and dimension of our matrix. Once we are done with that, we will create a heat map of first rows and columns. Here we have on the right side heat map of first rows and columns. Now we need to visualize the sum of columns. That's what we are going to do next. And this is the output that we will be getting. Distribution of the column count. Now, next what we are going to do is we are going to initialize the recommendation of movies per user at 10. So around 10 movies will be recommended to each users. Now we will see how the recommendations are predicted of user 1. So now we are predicting the recommendations for user 1. After that, we will come to our main output that we need to find is that we need to recommend movies to our user. So we will do that now, and this is our main output where 10 movies are getting recommended to our user. Titanic, MASH, Client, Fugitive and so on are the movies which have been recommended to our user. This is our most important output. After that, we have our recommendation matrix. That's all. This movie recommendation is a very important application of machine learning, and we have seen and gone through the code one by one how a recommendation system works and how our users get recommendations. Thank you.